SQL Server 2022 has a lot of new capabilities, and that does not exclude built-in query intelligence. Learn all about the new capabilities, see a cool demo this week on Data Exposed. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. We are jumping right back into the SQL Server 2022 Capabilities series with Bob Ward. Bob, thanks for joining us again. And today we're going to be talking about built-in query intelligence. And, I got to start with what does that even mean?
It sounds like a marketing phrase. I realize it's real technology, Anna. Remember our wheel of power? We're back to the wheel of power. We're in the second part of the wheel of power. Let me tell you exactly what this means, because we've been working on this technology for a while. So query tuning and performance analysis for SQL Server is really expensive and time-consuming. MSC is a customer of ours that's experts in this area. They're always looking for new innovations to make themselves better. The query store is something that's been a great tool for customers for a while. We're enhancing it right now in 2022. Turning it on by default for new databases. We're supporting read replicas now to do analysis of read replica queries. Yay! We're supporting something called query hints, allow you to shape plans without making application changes. And we've lit up some new scenarios for what we call intelligent query processing, getting you faster with no code changes. That's really what built-in query intelligence means. In some cases, using the query store. So the query store is a great thing on its own that we're enhancing in 2022, but I'd like to show you this story of what we call IQP Next Gen. So if you upgrade to SQL Server 2022, regardless of your compat level, doesn't matter where you are from previous versions, we're going to light up some new functionality. New percentile functions, something called optimized plan forcing, get you faster for compilation of your queries. But if you're on DB Compat 140, you get this plus, we'll enhance a concept called memory grant feedback. We've had that in the server before, but now we've improved the algorithm by default, and now we're going to persist it finally. We're going to use the query store as a way to store the feedback, so that if your plan cache is evicted or the server restarts, we'll still get to use that great functionality. This is all about self-healing, just getting faster by looking at feedback in the system. And then for DB Compat 160, we're going to do parameter-sensitive plan optimization. That's going to come into the product as well. Something called cardinal estimation feedback. Let's try to solve some of these CE model problems for you. And something called diagram parallelism DOP feedback. So that's been one that's really been plaguing customers for a while. All of those represent automation into the system, built-in query intelligence, where the query processor, and in some cases the query store, you can see here the query store is being used in some of these functionalities to make things faster. Don't forget, Anna, all this great technology that we've built in IQP from previous releases of SQL Server. And then we have a couple of principles here. We don't want to make anybody slower. That would be bad.
Right.
And then here's the cool thing. All these options you see can be turned off individually. So if you use DB Compat 160 and you don't like parameter-sensitive plan optimization, but you like the other two, you can turn that off as well, either at a database level or a query level. What I'd like to do is show you specifically parameter-sensitive plan optimization. That's one that's been a pain for a long time for customers.
Yeah, that sounds great.
So I'll do it through kind of like a diagram, my Bob's Crew diagram here. Let's say that you built, Anna, a stored procedure in SQL Server, which took a parameter value of an integer as a query to use for like a where clause. And you use, or the optimizer chooses like a seek plan for your query, because that's really fast for just a couple of rows. But I come along and run a stored procedure, the same one, after maybe the plan was evicted from cache for the first one, and I put in a 10. Well, that's got for like 1 million rows, so I need a scan, and that's fast for me, maybe sometimes even with parallelism. If you come back and run your stored procedure again, you're also going to get the scan, and that is bad. That's a degradation of performance. We call those scenarios parameter sniffing or parameter-sensitive plans. So in 2022, this is what we're going to do. Same scenario comes through here as well, the same type of situation. Now when you come back and run your procedure, we're going to fork and give each execution its own plan. Now it's not a plan per user, it's more like a bucket or an aggregation scenario, and we don't bloat the plan cache with too many of these things, right? But now for the first time ever, multiple plans for the same stored procedure can show up in cache. It's really kind of a groundbreaking type technology. Would you like to see this actually? Yeah, let's see the tech, right? So I've built this demonstration, let me show it to you. I've taken wide role importers in 2022, and I've created a stored procedure where I pass in a parameter value to go get like suppliers for stock items. So I took wide role importers, I create this proc. So you can see already though, I might be creating a scenario where depending on the value of the supplier, is going to depend on what kind of query plan is provided for a given query execution. So let's see an example of that. So right here, I'm going to supply a value of a 2, and I'm going to set on a timer so we can see real detailed timings of the query. And I'm going to run it, and I'm going to see what the plan looks like after I execute this. Now it happens just in a matter of less than a second, and it's using that index seek like we talked about to go after just a few rows. If you look at the timings down here, this happens like in 30 milliseconds to run, so it's very fast. Users are pretty happy with this type of execution. On the right-hand side, I'm going to simulate plan cache eviction, run the same proc with a value of 4. Now in this particular case, I kind of time-lapse this a little bit because this takes a while. Because for a 4, there's a bunch of rows needed, and in fact, I need a clustered index scan using parallelism here to get back this result. Now what if I run the first one, like I showed in the diagram here? It looks like it runs very, very fast. And in fact, you look at the plan here, notice it using a scan, but it seems like it was super quick, but go look at the timings. It is 10 times slower. So if you're running a workload with a lot of these, this could be bad. Let's see a workload example to show you really the difference here. I love perfmon to show these examples. I'm using batch requests per second and processor time. Batch requests to show you the throughput and processor time to show you kind of overall the impact on the system. So I've got a workload example to show you that first parameter value, but I'm running like 10 users at one time, all running the same query. It happens in a couple of seconds, and it's really great performance. And my throughput is great, low CPU time. Let's run the scan now. You can see here, the scan's going to finish in a few seconds, but it's simulating the same problems before. Plan was evicted from cache, so what I'd like to do is run the seek again to say, is it going to have the same time as before? Well, no. Remember that thing that was like 10 times slower? It gets exacerbated running 10 users at a time. Look at the degradation in performance of my workload, and look at the huge increase in CPU. It's because everybody's trying to scan the index in parallel for this workload. So I'm trying to think to myself, what do I do here? Well, I always have to go kill this query or kill this workload because it's taking so long to run. Now let's go over in Management Studio to see why are we seeing this problem? Like what is really going on here behind the scenes? So if you see here, I'm running a count of suppliers from this table, and you can see the skew in data below. For a supplier ID of say 2, I only get like 3 rows. Supplier ID of like 4, I have 4 million rows. So you can see I need multiple plans to give the best performance for different types of parameter values. So how do I solve this? I'm going to go and just set compat level to 160 for the database. I'm going to clear the procedure cache and query store to reset the workload. But I'm going to run the same tests that I did before and observe performance and perfmon. So let me restart perfmon again to kind of see what you can kind of see the performance comparison between the two runs. Let's run the seek query again. It's going to happen in just like 2 seconds here like it did before. Then I'll go run the scan as well. Now again, I'm simulating that plan cache eviction, running the scan. Now what's going to happen is when I run the workload the next time for the seek, we're going to get a new plan. We're going to go get the seek plan, and I'm going to see what I hope is the same performance. Yeah, a couple of seconds again, right?
Nice.
Yeah, and look at perfmon now. This is the part that really just shows it visually. See, the performance is the same as before. It's the exact same type of consistent performance I'm looking for. So this is the kind of type of technology that's really kind of groundbreaking. Now, I want to kind of dive in and show a little bit more what's going on behind the scenes using the query store. Even though it's not required to use parameter-sensitive plan optimization, I want to show you the insights behind it. So you can see I've got 2 plans. I've got one for a scan, I've got one for a seek. But for query store, it almost looks like there's 2 queries. We're using a concept called a variant. So what's really happening behind the scenes, and I'll show you through some queries here, I actually do have multiple query texts stored in the query store for the same store procedure, and I have a new DMV that allows me to go look at this information. So if you kind of scroll over here, you can see the query's been appended with this new text called plan per value with something called a query variant ID. It has the object ID of the store procedure as well. Both of these are in the query store, but here's the beauty of it. If you keep scrolling across a little bit here, you can see, even though there are 2 texts for this, they hash the same query hash value. So now, even though these are really the same query and they appear twice, I can use query hash to compare and say, okay, what was the performance of this query over time? I can even dive into, see, here's the different plans for each of those.
Right.
I can dive into the XML plan as well. A lot of people like to go look at that. And if you're into the XML plan, you can go to the details and see here the same query variant text. You kind of see this over to the right here, that plan per value option. You also see the object ID in there as well to see like what stored procedure this belonged to. I can run another query to go actually find out in the query store what was the stored procedure related to this. And in fact, you see here the object name shows up for both of those variants because we have this concept called the dispatcher. That's like the parent plan as part of the stored procedure overall. So yeah, and here's the stored procedure itself. So that's kind of a glance and looking at what is possible for parameter-sensitive plan optimization.
Wow, that's pretty cool, pretty powerful. And then I also liked how you kind of dove into some of those details, how we can see what's really going on.
Well, you know, SQL people want to go behind the scenes and see what's really going on, the insights of what happened, right?
For sure, yeah. And now I wanted to kind of shift. You mentioned this DOP thing. Can you tell us a little bit more about that and what we're doing?
Yeah, you know, the pain of max DOP has been around for a long time in SQL Server. And the whole concept is that SQL Server uses parallelism in many cases for queries, and it's not necessarily a bad thing, but I need to control it. And setting the right value for the database, the instance, the query, like how do I do that? And in fact, Anna, did you know the more degree of parallelism for a query, the more threads, the more CPUs required. The less DOP, the less threads. The problem is, though, it's a juggling or balancing act. How do I get parallel efficiency? In other words, how do I figure out the min DOP to run a query to get the best performance but use the less CPU?
Right.
So we have a feature called DOP feedback built into the engine. You use dbcompat 160, you set a database compat level, and this is kind of load behind the scenes how it works. The query processor will work in conjunction with the query store to go and take a query if it's eligible, and it kind of lowers the DOP to see, is it still the same performance, but can I get less CPU overhead? I've been able to use this technology to go from a DOP of 16 down to 4 for a query, achieve the same query performance duration, but free up like 40% more CPU for the rest of the workers in my system. So it's a way for us to use a feedback mechanism to get you that parallel efficiency so that parallelism isn't necessarily bad in your system.
Wow, you know, Bob, that's pretty powerful stuff.
Well, that's why it's called built-in query intelligence, right? I mean, it's getting fast with no code changes, things built into the engine. And Anna, we've worked on Azure SQL together. This is SQL Edge to Cloud. It's in the query processor, so it works on Azure SQL, anywhere SQL exists.
Awesome. So what about everything we've seen?
I mean, we packed in a lot, right? We got new query store capabilities. You upgrade to SQL Server 2022. With any dbcompat level, you get functionality. You go to dbcompat like 140, you get enhancements to memory grant feedback. You go to 160, you get all sorts of things like parameter-sensitive plan optimization, CE feedback, and DOP feedback. So we're also bringing in all those innovations we did in previous versions. So built-in query intelligence with the query store, plus the next generation of intelligent query processing are some of the biggest capabilities we have in SQL Server 2022.
Awesome. Well, Bob, once again, great to have you on the show. We learned a lot in this SQL Server 2022 series so far, and it's not over yet. So viewers, if you like this episode, go ahead and give it a like, leave us a comment, and let us know what you think of the new built-in query intelligence capabilities. Check out the links in the description for all the ways you can get hands-on, see the deck, all sorts of stuff, and we hope to see you next time on Data Exposed.